Student, the next question is 10 cm cube of a solution of pH 3.7 is diluted by adding 90 cm cube of water, the pH of diluted solution. To calculate the pH of the diluted solution, first we need to find the concentration after dilution, and the concentration or the molarity after dilution can be calculated by using the formula M1V1 is equal to M2V2, where M1 is molarity before dilution, that is the concentration before dilution, V1 is the volume before dilution, M2 is molarity after dilution, and V2 is the volume after dilution. First we need to calculate the molarity after dilution, and then only we can calculate the pH of the solution. So let us start the solution of the problem. They have given us a solution whose pH is equal to 3.7. Now first you need to calculate the H plus ion concentration, the molarity of this solution with pH 3.7. Then from this concentration you should calculate the concentration after dilution, and then only you can calculate the pH. pH 3.7 indicates H plus ion concentration is equal to antilog of minus 3.7. We have discussed such type of problems where we calculated the antilog of a number. Now antilog of 3.7 cannot be calculated because it is negative, hence you need to convert the mantis of positive, that is you should add and subtract 1, minus 1 plus 1, so hence it becomes antilogarithm of 4 bar 0.3, that is equal to antilogarithm of 0.3 is 2, because log 2 is equal to 0.3010, hence antilog of 0.3 should be equal to 2. So it will be equal to 2 into 10 to the power minus 4 molar. So the H plus ion concentration of a solution with pH 3.7 is 2 into 10 to the power minus 4 molar. So this is the initial concentration of the solution. This is diluted to diluted by adding 90 cm cube of water. Let us calculate the concentration after dilution. This can be calculated using the formula M1V1 is equal to M2V2. M1 is molarity before dilution, that is 2 into 10 to the power minus 4. V1 is the volume before dilution, that is 10 cm cube. That is M2 molarity after dilution, which we should calculate, because once we calculate the molarity after dilution, you can calculate the pH of the diluted solution, into volume. To 10 cm cube we have added 90 cm cube, so the total volume will be equal to 100. So M2 will be, that is molarity after dilution, will be equal to 2 into 10 to the power minus 4 into 10 divided by 100. 10 to the power 1, if it goes to the numerator it becomes 10 to the power minus 1, so you get 2 into 10 to the power minus 5. So this is the molarity after dilution. Once you calculate the molarity after dilution, you can calculate the pH of the solution, and pH of the diluted solution is equal to pH is equal to minus log of H plus ion concentration, that is equal to minus log of 2 into 10 to the power minus 5. You can easily predict the values by the method that we have discussed. If it is one digit number and the power is 5, so the pH should lie in the range of 4 to 5, or even you can calculate it. So minus log 2 plus log of 10 to the power minus 5, that is equal to minus outside log 2 is 0.3010, log of 10 to the power of minus 5 is minus 5 log 10, that will be equal to 4.7. Hence option C is the right answer. You can observe in this problem, that is we have diluted a solution from 10 cm cube to 100 cm cube, that is by adding 90 cm cube of water. You can just notice the change in pH. The pH has changed from 3.7 to 4.7. That is, if you dilute a solution 10 times, the pH will increase by 1. So hence that is also, you can just remember it if you get a such type of problem, so that you can directly mark it. That is, if you dilute it 10 times, the pH will increase by 1. So here the pH of the diluted solution is 4.7. Students, let's discuss the next problem. Students, let's discuss the next question. The question goes like this. The pH of a solution is 7. To this solution, sufficient base is added to increase the pH to 12. The increase in OH minus ion concentration. Options are option A 5 times, option B 1000 times, option C 10 to the power 5 times, and option D 4 times. So to calculate the increase in the OH minus ion concentration, first we should predict the OH minus ion concentration for a solution with pH 7 and then with pH 12, and then we can compare it. Let us see the solution of this. They have given a solution whose pH is a 7. It is a sufficient base is added so that the pH of the solution increases to 12. From the pH, we cannot calculate the OH minus ion concentration. To calculate the OH minus ion concentration, we require the pOH. We know that pH plus pOH is equal to 14. If a pH 7 is equal to 7, the pOH will be equal to 7. If a pH is equal to 12, then the pOH will be equal to 2, because pH plus pOH is equal to 14. So the pOH has been decreased from 7 to 2. pOH 7 means OH minus ion concentration is equal to 10 to the power minus 7. pH 2 means OH minus ion concentration is equal to 10 to the power minus 2. If you look at this, the OH minus ion concentration has increased from 10 to the power minus 7 to 10 to the power minus 2. This can be done by adding a base 10 to the power 5 times. That is, so the answer is option C. Students, let's discuss the next question. Student, the next question is 100 ml of 0.1 molar HCl and 50 ml of 0.05 molar NaOH are mixed. The pH of resulting solution. Your options are option A 1.3, option B 1.8, option C 2.12, and option D 3.42. Here they have given you a mixture of HCl and NaOH. While calculating the pH, first you should find the nature of the solution after mixing. Why? Because HCl, when it combines with NaOH, you get salt plus water. If the concentration of HCl is more, then the resulting solution will be acidic. If the number of moles or the concentration of NaOH is more, then the resulting solution will be basic. In this problem, they have given us HCl and NaOH. So when you mix HCl and NaOH, neutralization takes place, and the nature of the solution depends upon the concentration of the acid or the concentration of the base that is present. If the number of moles of acid is more in the solution, then the resulting solution will be acidic. If the number of moles of base is more, then the resulting solution will be basic. First we need to calculate find the nature of the solution. Then based on that we can calculate the H plus or OH minus ion concentration. Then we can predict the pH of the solution. First we will try to find the number of moles of HCl, then we will find the number of moles of NaOH, then we will see after mixing what is the remaining moles, whether HCl is remaining or NaOH is remaining. Based on that we will go for the calculation of the pH. Let's start the problem, guys. Now, number of moles is given by the formula molarity into volume. So number of moles of HCl is equal to molarity of HCl into volume of HCl, provided volume is in liters. If you take volume in ml, you get millimoles. So molarity is given as 0.1, volume as 100 ml, so it will be equal to 0.1. 0.1 into 0.1, it will be equal to 0.01 mole. This is the moles of HCl that is given. Let us calculate the number of moles of NaOH. Now, number of moles of NaOH is equal to molarity into volume, that is 0.05 into volume is 0.05. Because 50 ml in liters, it will be equal to 0.05 liters, that will be equal to 0.0025 moles. If we compare the moles of HCl and the moles of NaOH they have added, the added HCl quantity is more as compared to the NaOH. Hence, after mixing, the resulting solution will be acidic and the remaining will be the excess of HCl that is present. So the number of moles of HCl present, remaining HCl. remaining HCl in the solution. That will be equal to 0.01 minus 0.0025, that will be equal to 0.0075 mole. This is the moles of HCl that is present. But we require the concentration of H plus ion. See why I am writing the remaining moles of HCl. Why? Because HCl concentration is more than the NaOH. In case if concentration of NaOH was more than HCl, then we would have taken the remaining NaOH. Here HCl is more, hence the remaining HCl is 0.0075 mole. We require the concentration of H plus ion, and you know that concentration or the molarity is given by the formula number of moles divided by the volume. So the number of moles of HCl is equal to 0.0075 divided by the volume. Volume is 100 plus 50, that will be equal to 150, that will be equal to 0.15 liter. If you calculate it, you get value equal to 0.05 molar. So this is the concentration of the remaining HCl. So once you have got the concentration of HCl, you can calculate the pH of the solution, and pH of the solution is given by the formula pH is equal to minus log of H plus ion concentration, that is equal to minus log of 0.05, that is equal to minus log of 5 into 10 to the power minus 2. So minus outside, log of A into B, log A plus log B, that is log 5.6990 plus log of 10 to the power minus 2, that is minus 2 log 10. If we calculate it, you will get the answer equal to 1.3. Hence option A, that is pH equal to 1.3, is the right answer. Students, let's discuss the next problem.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.